Okay, so lastly, we are going to get into multiplying decimals by decimals. This is the last video of the week of April 27th to May the 1st regarding to math, and you need to watch every other video before getting to this one in order to make sure that you're following along. Even if you've been kind of making it your own way through the booklet up until this point, because of how I've been explaining things, you want those other videos' experience before you get into here, or I may use a term that you're not familiar with. So we're going to be multiplying decimals by decimals. And I won't lie to you, it's pretty ugly. It's necessary if you're ever having to uh, do anything relating to measurement or money. These kinds of calculations are going to be necessary for you to be able to do. So we are talking about place value, and it says how many decimal places in the first question does each number have. So we're just gearing up for the idea of numbers of decimal places. So a decimal place is a place value after the decimal. So just to clarify that first question, if I have 201 and 4/10, then I have one decimal place. That's all I have. That's the answer for number one. Now, it's already doing what I suggested that you should be doing from the previous video. It's starting to get you into the idea of converting things into a fraction. So if I have 2/10, I want to make that 2/10. If I'm looking at question 2 and it shows me 0.2, that's 2/10, which looks like that. I do not want to simplify. And if it is simplified, I want to make the lowest common denominator a 10, a 100, or a 1000 in order to do my math today. So anytime I see a decimal, as long as my denominator is 10, 100, or 1000, I'm looking great. So now I want to get into the concept of multiplying. If I had 3 times 3, I have 3 groups. And this 3 are things. I have 3 groups of apples, of 3 apples each. I have 3 groups of 3 bananas each. I don't know why I'm on a fruit thing. Maybe I should just go eat some more breakfast. But the idea is that whenever I am using multiplication, I am thinking groups of. Now, when we do regular multiplication, we are dealing with whole numbers. It's very nice and it's very pretty. I have a whole banana, which means if I have 3 groups of 3 whole bananas, I don't have to worry about anything except for counting. 1, 2, 3, 1, 2, 3, 1, 2, 3. I have 9 bananas. However, when we get into decimals, I still have groups of, but I don't have even one whole group of a thing. Think about that. Let's say I have a chocolate bar and it's 4 pieces. And I want to make half a group. Well, the idea of half a group is equally confusing. But moreover than that, I want to make half of a group of only 1 out of 4 pieces, or 25. So I want to make a group out of it, then cut it in half. But it's already not even a whole chocolate bar. It's 1 out of 4 pieces of a chocolate bar. And if you're listening to this and you're going, Mr. Hopper, I am so lost, don't worry. This is a concept that while we need to understand what it's asking us, we also don't have to think like this in order to solve the decimals. So once more, groups of. And that's why it's going to be messy. If you listened to this whole blab right now and thought it was messy, that's the point. I want you to be prepared that the numbers you get when you multiply decimals aren't going to get bigger all the time. In fact, sometimes it's going to seem to get really small if you multiply a decimal by another decimal. So when we get back to it, when we multiply a decimal by a decimal, we are converting to a fraction first. Multiplying fractions is easy. Multiplying decimals and getting your head around all of that is not. So we'll take a look at question 3. It says, shade 2 rows to show 2/10. Then shade 3 columns to show 3/10. So or 3 columns to show 3/10. I don't think that made sense the way they set up that question. Anyways, they're trying to show you with that 100 chart that when I'm multiplying and I'm trying to show tenths, yeah, I've got tenths in my 100 square, but I want to show tenths in another 100 square, and it doesn't end up equaling tenths anymore. So I've taken 2/10 in question 3a, and I said, well, I also want to turn it into groups of 3/10. And to do that, it is not going to equal 6/10. That doesn't happen because we have decimals, which means we're shifting the number of zeros one to the right. That sounds confusing. Let's turn it into fractions and see if it makes more sense. I have 2/10 times 3/10. 2 times 3 does equal 6, but notice 10 times 10 equals 100. So 2/10 times 3/10 equals 6/100, which is smaller than even 1/10. That number that we got ended up being smaller than either of the starting decimals. And that's because we're dealing with a decimal multiplied by a decimal. We'll do another one. It says multiply 2/10 by 5/10. So I would like you to try and draw out 2/10. So I would shade 100 chart. Oh, I'm sorry, I've just turned off my marker. So if I have 100 chart, and yes, pending my terrible drawing, this would have 100 perfect squares in it. I would want you to color in one color, in a pencil crayon, 2/10. I'd color those in. Tell you what, I'll even color them a different color. I've got red, and I've got red, 2/10. Then in a second color, I would want to color down vertically how many columns. Well, it says here 5/10, so I've got 1, 2, 3, 4. My goodness. My touch screen's being funny. 5. Then if I were looking at an actual hundreds chart, I would want to count the number of squares that have the two colors in them. And I go, okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Those two colors where they intersect, I would get 10. But what do I have? Not out of 10. I have 10 out of 100 squares that have this two colors in them. I can simplify this and I can say 1/10. In decimal form, I could say, hey, Mr. Hopper, I have 10 hundredths. You could also say, hey, Mr. Hopper, I have 1/10. Same number. So that's how you do it with a chart. And you're welcome to use a bunch of 100 charts if you so choose. But again, I do prefer the using fractions. So I'm going to go back to this color. I have 2/10 times 5/10. Well, 2 times 5 equals 10. 10 times 10 equals 100. 10 hundredths. So either way works fine. Question 4, you need to write a multiplication sentence for each figure. And I do believe that they used to be shaded in. It looks like it's very faded. I want for you to shade in a rectangle inside the 100 chart. And then you're going to tell me what that decimal is, what that fraction is, and how you got that fraction. So you're shading that in, and then you're telling me how you got it. So multiply the fractions, see page 39. You don't have page 39. We've gone over how to multiply fractions. Numerator times numerator, denominator times denominator. And on the back side is when we get into strictly decimals. Turning to page 82, question 8. This is the last example I'm going to do. You have 5/10 times 8/10. I have 5, 0.5 times 0.8. I want to convert them to fractions. I don't want to think of them as whole numbers because that's where you're going to forget where to put your decimal. If you want to try it, okay, but I would rather you try and convert it to fractions. So let's do 5/10 times 8/10, 40. If you insist on doing it the way that the sheet says, even though I think that leaves more room for error, then we take away all the decimals and we pretend that we are dealing with whole numbers. 5 times 8 equals 40. Now it says that the decimals, we count the number of decimal places they have. So this one has 1 decimal place. This one has 1 decimal place, which means that I need to have 2 decimal places in my answer because 1 and 1 makes 2 decimal places. If that doesn't make sense, I'm with you. That can get tricky to get your head around. So that is how we multiply a decimal by a decimal. Ultimately, the most reliable way for you to do that is to convert into a fraction. You have to keep your eye on the decimal place always, always, always when you're dealing with decimals. And then you have to, after you're done making a fraction, you have to convert this back into a decimal. That's going to be it for our videos today. I look forward to seeing all of you at 10:30 or later. And please reach out with an email asking a question. I would rather that you ask a question and not have your work done because we're working on it together than for you to guess and rush and send me some work that is definitely not done properly. And that's been happening a lot lately, and I would really appreciate that you would show up and ask questions rather than guess just to get it over with. So we're going to leave it there, and I will see some of you soon. Bye-bye.